Homework number 18. We'll cover finding average rate of change 3 different ways, and then we'll combine them all together. Let's start with finding average rate of change from a table. When finding average rate of change, you need 2 points. And the x values of those 2 points will be provided to you in the interval. So we're looking for only the change between the point with an x-coordinate of 12 and the point with an x-coordinate of 24. You need to go to the table to find their y values. Once you find those values, you can put them in the slope formula. Y minus y over x minus x. Be careful that you are using the same order. So if you subtract y2 from y1, then you must subtract x2 from x1. It's okay to reverse the order like this. That is okay. But you cannot reverse the order in different directions. So let's compute the math for 48 minus 28 and 24 minus 12. I suggest entering the entire fraction at one time. You don't need to show any partial math here. Once entered, the calculator will reduce it for you. So we're going to type 5/3 here in the answer box. Let's try this one more time. Identify the x coordinates from the interval that's given, and use those x coordinates to find the y values from the table. So we've got 4 and 57, and 10 and 51. Set up your slope fraction, y minus y over x minus x, and compute. Use a calculator to check your work. Alright, now we're going to try the next topic, which is the second topic. We'll be finding the average rate of change from an equation, and we'll follow the same process. You still need to look at a table of points, and you still need to be given the x-coordinate values from the interval over here. So we know that our x-coordinates are going to be -5 and +6, and you can either use your TI-84 to type this equation into the y equals button and then look at the table of points, or you can mathematically compute it yourself by substituting in the value for x in every position that you see in x and find your value of y. I'm going to use my TI-84 to speed up the process. So I'm going to go into my y equals button. I'm going to type in x squared plus x minus 7. Then I'm going to hit second table to view the points. Oops, or I hit graph. Second table. And now I'm going to look for -5, which is 13. And then +6, which is 35. Now I'm going to set up my subtraction fraction here. 35 minus 13 over 6 minus -5. And then, just to be safe, I'm going to compute this on the calculator. Set up my fraction here. Alpha y equals 35 minus 13 over 6 minus -5. Looks like I get 2. So I'm going to type that here and compute. Again, you type this equation into your y equals button and you look in the table for the y values for -3 and +7. Let's take a look at the third topic from a graph. So when you find average rate of change from a graph, they'll give you the interval again. So from -5 on the x-axis, you need to go down to find the function. So at -5, I need to move down 5 spaces along the x-axis to get to the function. Oops, sorry, 6 spaces. These go by 2's. And then for +3 on the x-axis, I'm going to go up 5 times, but each one is 2, so that's 10 units. So what they're really looking for us to find is the average rate of change from this value to that value along this straight line. So we're going to compute 10 minus -6, 3 minus -5, and we're going to get 16 over 8, which is a slope of, or rate of change of 2. So we're going to type that in here, and we'll be all set. Again, you're trying to find the average rate of change between an x-coordinate of 2 and 3, and once you find the y values, you can compute the slope along that line. Let's take a look at the last one, which is comparing all 3 of those different methods. So in this question, they're telling you you have function f, which is the graph, function g, which is this table down here, and then function h, which off the screen is this equation. So they want you to compare the rates of change for all 3 functions and find the ones that are least to greatest. So what we're going to do first here is identify the actual x-coordinate values from the interval, which is -5 and +3. So from there, we're going to scroll down and find that value for all 3 of these functions. So from -5 to +3, these are our x and y coordinates. -5, 4, +3, -12. Over here, we have -5 and 3, so that's 72 minus 8 over -5 minus 3. And over here, I have an equation, so I'll need my calculator. X squared minus 5x minus 29. So let's take a look here. X squared minus 5x minus 29. I'm going to look at the table, second graph, and again I need -5, which is going to be -5, 21, and +3, which is -35. And now all I need to do is compute all of these rates of change. So -12 minus 4, 3 minus -5, and then down here, -35 minus 21, and 3 minus -5. Alright, let's take a look here. This one is going to be -16 over 8, which is -2. This one over here is going to be 64 over -8, which is -8. And this one's going to be -56 over 8, which is -7. Alright, so we've got -2, -8, -7. This one is the least, that's function g. Then it's this one here, which is function h. And then it's this one here, which is function f. So this is the order from least to greatest. G, H, F. So I'm going to scroll down and choose the one that has that order. G, H, F. All right. Transformations of functions. We'll do this 3 times. The first time you can type any number you want in here to trial and error. But again, you're looking for understanding that transformations inside the parentheses are left or right, and that a transformation outside of the parentheses is up or down. Right? So it looks like if my vertex starts at the origin, and then my vertex ends up over here, it looks like I'm going to the right, and I'm going up. So that means I need to have new numbers in these two locations. So if I'm moving to the right, that is a transformation inside the grouping symbol. Go to the right. And then I'm going to add 3 to make it go up. And once I have it situated in the space that I want, I can click Submit the answer. Alright, this function is pretty neat looking. Looks like I want it to go upside down. That's called a reflection. And that happens in front of the X symbol. So that means I need to negate it to flip it around. And if I look at the vertex here and the vertex there, it looks like I want it to move 1, 2, 3 to the right. And that again is a -3 move. So I'm going to type -3 here. And now I need to move this vertex up to this position, which is a change of 6 units. So I'm going to type a 6 up here. There we go, and I got my submit button by trying the next topic on transformations. So let's see here. It looks like it has reflected, so that means I need a negative. You choose this one. Right? You see that it has that negative sign with the X, but you see how this has a plus sign outside of the parentheses? And this one has a +3 inside of the parentheses? That's what's different. This is a reflection. This is also a reflection. It doesn't matter if that negative sign is inside the group or outside of the group. So it doesn't matter. This location is still a reflection. What does matter is this value. If it's outside the group, that's a move up or down. If it's inside the group, that's a move left or right. So inside the parentheses, the moves are plus is left and minus is right. So it looks like we have moved 3 units to the left, so we need a plus sign. Again, this one has moved both up and down and left or right. So we can see that we've moved 1, 2, 3, 4 units to the right. That's a -4 inside the grouping symbol. That's a -4 inside the grouping symbol. So that means that we've eliminated those 2 choices. And now we notice that the graph moved down 5, and that means we need a -5 value. All right, let's take a look at the next section here on transformations. In this one, they're going to ask you to move these points to represent this transformation here. +3 inside the grouping symbol and a -5 outside the grouping symbol. So if you choose the green vertex point, you can move the entire function and you don't have to touch the blue values at all. The blue buttons will only be used for dilations or reflections. So the green button can make a shift 3 units left, which is what +3 inside the group means, and then the -5 outside the group is a shift 5 down. So I've been able to move the entire function by just clicking that green button. Again, a 2 inside the grouping symbol is left or right. A 2 outside the grouping symbol is up or down. Inside, a negative is right, and outside, negative is down. One more time. Inside, positive is left, and outside, positive is up. So use that green circle to move the entire function at once. Alright, the last two topics is for our next unit on systems of equations. So for the first two questions, you'll be given two linear functions. They will already be graphed. You simply need to find the point of intersection. That point of intersection is your solution. The solution has two values, an x and a y. They can be typed separately, or they can be typed together like this as an ordered pair, which is what you're going to type in the solution box. So let's take a look. Our solution point is -4, -5. So we'll type that here. And submit. Again, find that point of intersection and type it here in the solution box. Last section is to graph the linear functions yourself. So in order to do that, you need to pay attention to the y-intercept and the slope. This one has a y-intercept of +3 and a slope of invisible 1/1. So that's up 1, right 1, up 1, right 1. This is how your line will look. In order to graph it, using the Delta Math interface here, you're going to click one time on the y-intercept, and then that will start a line that you can rotate or move in any direction. So I'm going to move my mouse up 1 and over 1 to click. That first graph is done. Now I'm going to graph the second graph, again, by clicking once on the y-intercept of -6 to start a line, and then by moving along that line down 1 unit and right 2 units. Now that I have graphed both lines, I can identify that point of intersection, which is -6, -3. Again, in parentheses, and using a comma to separate, you can list your point. Start by graphing at the y-intercept. Follow the slope of +1, +3. Start at the y-intercept, -6, and that slope is -1 over +1. That negative sign can only be used once. So if I use this, it goes with one number only. Once graphed, you can identify that point of intersection, and you can type it in this answer key. That concludes homework number 18.